All right, so my name is Jacob Weirson, and we're going to be covering ITM presentation block 4. So let's dive in. Thanks for joining me. So what we're going to be covering today from block 4 is we're going to be talking about two things. We're going to talk about data models and their usefulness. Essentially, what are data models? How are they used by computer programmers and engineers? And then we're going to talk about databases and how they operate within the framework of information systems and softwares. So some two very important parts of information that we're going to be discussing today. So the first thing is data modeling. What essentially is data modeling? How do computer programmers and engineers find them useful? And why do we need them in the first place? What is a data model? You see sort of a diagram on the right-hand side. What is a data model to begin with? And before we even delve into the details of that, we're going to have to start with what is a model in the first place. Well, when architects and builders build a building or an infrastructure, they start with a small model at first. So a model essentially is a simple representation of the real deal, of the real thing. They use this model to maintain, improve, to see what they need to improve, to see if it even works in the first place, and to see how it's going to look like in real life. It applies to information technology as well. These data models are essentially blueprints for the computer engineers and programmers for them to, it is the blueprint to their software program or their information system. How can they, when they see this simple representation, a smaller, much more simpler, and much more summarized version of their final product, of their program or software, what is it that they need to change when they see this simple representation? Because it's much more simpler than their final product. What is it that they need to improve? Does it work? Will it work? How will it look to people? It's the blueprints of their software program, and it is very vital for engineers and programmers to see this because they, in essence, see how it's going to work, and do they need to change things before they start constructing it? And all this process for data modeling begins way before they even start constructing the program itself. And it is best viewed in diagrams, such as in the bottom right-hand corner, or charts or things like that. That is essentially data models are represented in that context. But it's very crucial for engineers and programmers because it allows them to see their software program and information system before they construct it and what they need to improve on. Next, we're going to move on to databases. How are databases useful? On how do they provide for easy access for computers and storage within computers? So the best way to describe a database to someone is by telling them it is essentially a computerized filing system. For any business or corporation, you will always have file cabinets, file systems that have folders and tabs that will tell you what information and what paperwork is stored into what. And that is essentially what a database is. It is a computerized form where any type of information is stored on the computer, and it provides easy access where anyone can access that form of information. So databases, they store multiple facets of information. They can store your personal information, business transactions, anything that you save on the computer. It can save, store, and organize, and databases provide easy access for the computer to retrieve information. It provides easy access for engineers and programmers that want to access easy information, or for us who want to access a file, or we want to open a folder. Those are very easy things for us to do on a computer, and the reason for that is because of databases. They provide that organization and that simple, easy access for us to do, and it's very beneficial for us. And like I said, databases or organizations, it is a form of organization for information systems. There are two common types of organization of information systems that I found in the research that I conducted for Block 4. One of them being relational databases, which is essentially, it's kind of like tabs on a folder. There are tabs on a computer, and under these tabs are different sorts of information. For example, if I have my personal information on one tab, I will have files and levels of organization that have to do with my personal information saved and stored into this one facet of a database. And it is essentially a storage system and a way of organization. Distributed database is essentially relational database. So we have these tabs, we have these different boxes, if you will, of information stored on a computer, on an information system, and which can be utilized over a wide range of networks. So it can be utilized, online through different facets of networks, wherever you are in the world. That is essentially what distributed databases is. The information and the storage is distributed, in a wide variety of networks. So concluding on what we've covered in Block 4, we've talked about the necessity of data models and databases, how they provide help for engineers and programmers to see their software system before they construct it. How can they improve it? What needs to be changed for the data model and for databases? How information is stored, how it is easy for us and the computer to access, and how it is essentially organized. And that is what we learned in Block 4. Hope you enjoyed the presentation and hope you found it useful. Thanks a lot.